Welcome to Frank Coca's Big Book of Physics, where we're all about teaching physics in the most fun way possible. And today, we will be discussing how the square cube law would save us from the movie monsters. Now let me just start off by saying I love movies of giant monsters in them. I think they're really cool, it's really fun to watch. However, there's a very big scientific inaccuracy, and today we're going to learn about the square cube law, how it works, and most importantly, how the physics of the square cube law would save us from the terror of giant monsters. And we will be using my personal favorite, Godzilla. Now, it's important to note that we are using the 2014 American version of the character, and that's simply because, well, he's one of the largest incarnations, and there's an official mass on him of 90,000 tons, which is just insane. For some perspective, the Titanic was 46,328 tons, so he's really big, to simplify it. But today we're going to learn about how he's just too big. Alright, so first we're going to have to learn how the square cube law works. Basically, in short, the square cube law demonstrates as an object gets heavier faster than they get stronger as they increase in size. So down here you can see a cube has one face tall, one face wide. So it's surface area, which is squared, 1 times 1 is equals to 1, and volume, 1 times 1 times 1 is also equal to 1. However, you have to understand that the surface area at a cross section, which holds up the rest of the weight of the object, so in this case here, it'd be that bottom face. So that one face has to hold up the weight of the rest of the object. Now, that is only squared. The volume of the object and its weight, what has to be held up, is cubed. So to demonstrate, here we have a cube that's 4 faces wide and tall, and its surface area, 4 times 4 is 16, and its volume, 4 times 4 times 4 is 64. As you can see here, we only quadrupled the size of the object, but its mass went up by 64 times. That's crazy. It only gets crazier as the object gets heavier and heavier and heavier. It gets to a point that no matter how big it is and how much surface area it has, how much strength, it's just not going to be enough to support the weight, its volume. Here we just have one more little example. As you can see, the volume is increasing faster than the area. So how exactly would this kill Godzilla? So one thing that we made sure, well, we have a little model here to explain. So here's Godzilla. His legs, as you can see, are massive. And this kind of makes sense as it would have to hold up all his weight. But something to remember is that in proportion to him, those legs are actually pretty small. So as we just discussed, Godzilla is 90,000 tons. He's super heavy. Now, we don't know his exact dimensions, but what this would mean is, either way, his volume would be many, 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 and so many more many times larger than his surface area. What's important to know is, okay, so let's say he was a cube, which obviously he's not. He'd be too heavy for that one face to hold up, and that's just a whole base there. He actually won't have that strong base that a cube would. It's only those 2 legs that are holding up all his weight, which means instead of a surface area spread out, it's just those 2 legs to hold up all 90,000 tons. Another thing to remember is that he's made of flesh and bones like the rest of us, not concrete or steel. He's just it's not strong enough, like you would see in construction. So basically, in short, there's just simply too much weight for his legs to support, especially being bipedal with only 2 legs and not 4 to spread the weight over a larger surface area. If Godzilla was to step on land out of the buoyancy of water, he would collapse and die, crushed by his own weight. So rest in peace, Godzilla. It's just crazy. All the weapons and bombs they thrown at him, and all it took was just physics and the square cube law. Thank you for watching.